Welcome to lesson number 19. From the look of things, we're going to talk about measuring today. I've laid out a whole array of different kinds of ways to measure linear, wall thickness, transferring, so on. And I want to kind of take you through these in groups. So first thing I want to talk about is the very basic measuring things that you need to have. I have a lot of different calipers here, from some very, very precise ones which we'll never use. I think for the general woodworker, a digital caliper probably is not a good idea. You got batteries, electronics, things that are subject to vibration and dust. Sometimes these dial calipers, which are laid out in hundredths of an inch, which are a little difficult for us to transfer from 3/8 to 375 thousandths. They work, but not necessary. This is the caliper that you need. It's the cheapest metal one I could find. Several reasons. Number one, it's metal, and I'm going to transfer marks onto my wood while it's moving from using the different aspects of this thing. If it's plastic, I could melt them. Second thing, because it's inexpensive, if I damage it, I'll throw it away. The scale on here to read is more than accurate. If I want a 2-inch caliper, a 2-inch tenon, I just set it to roughly 2 inches, and that's close enough. I'm going to show you how to use all the different aspects of this tool in just a couple of minutes. Got to have one of these. Obviously some marking instruments. I'll leave that aside for later. And what we call a scale, or a 6-inch ruler. I brought a bunch of them. Here's a cheap, inexpensive one. Very light, but it measures from the very end, and the corners down here are really square. That's a key in the fact there's a straight edge. Here's a smaller one, which is easier to read because the numbers are raised and against a dark background, but I find it a little too flimsy to keep in my pocket and find. Here's another one, easier to read. But my preference is this one. This is from a place called iGaging, which you can pick up at most hardware stores. It's thick, it's heavy. The hook on the end allows me to come over the edge and take a reading any direction like that. So we need a straight edge. Put that in our set. It's nice to have a square. There's a lot of times that we need to check the squareness of something. Here's a really good one, a Starrett. And here's one of a set of 3 that I got that was made in, I believe, India. Pretty doggone close. So this works out just fine. We need to set the height, the table setting for our bandsaw, check the tilt of the blade for our table saw, various different things like that. A small, not a great big carpenter square. They're too big and too clumsy, but a smaller square would be nice to have. The last thing in your basic set is a pair of calipers. These are outside measuring calipers. I can set them to any dimension simply by turning the knob. I have modified them by taking these tips, which came very sharp, rounding them off, because there's a few times I'm going to put it over a piece of spinning wood, and I don't want that to catch or grab. So set of calipers. There's your basic set that you really need to have. There's some things out on the front of the table I'll talk about later when we talk about measuring wall thicknesses inside and outside of bowls and vessels. But you have to have something like this. Other things that really, really help. I added a center punch a long time ago to my set because I am able to go in after I mark a piece of wood and punch a little indent here. And when I put this piece onto the lathe like this, it's doggone hard to see that penciled on X, but it's easy to feel and find that little indent when I'm trying to get my live center or spur drive into the spot. So this is really helpful, and these again are only $3 or $4 at the discount stores. We use a lot of these in our classroom for finding centers. This is for finding center of something round. The other side, because this is 90 degrees, is for finding centers of things that are square. It's a convenience. Not necessary. If the piece is square, I can always just connect the corners. But if it's round, I've got to do something else. So this is a convenience, and I find I use it a lot, but not necessary. I've made up a couple of other little simple things. This is laid out in inches, as you can tell, crudely, but allows me to measure depths of things simply by sticking it in, checking where my finger rests on it. It's a convenience to have. For measuring things, excuse me, went out of the picture for a second. For measuring depth of something, I made this up, a little dowel and a piece of wood. Stick it in, push it to the bottom. There's the depth of that vessel, because I can rest it like that. Another convenience. Well, I think the most important piece in our set, really, is this pair of calipers, because it measures in 3 different ways. And I want to show you how those are all important, specifically in creating a tenon for a bowl or a spindle project. So let me shove this out of the way and just go on with that little aspect and just create a little workspace. Here's a piece of wood, and I want to put it into this chuck. So I want to get the tenon properly fit. Now, I know these are square jaws for the chucks we use. Same techniques will apply if you have a dovetailed jaw. So I need to know, I want the jaws set about here, what is the diameter I need? So I'm going to take my calipers and just measure across the widest portion. I've used the inside measuring capability. I can then transfer that to the end of my billet. And now I know the diameter of the tenon. How deep do I want it to go? Well, that's the depth of my jaw, and I don't want it quite that deep, so I'm going to back it off just a little bit so it doesn't touch. And there is the depth of the tenon. So if I turn away all the wood from here to here, all this portion I blackened, I'll have a tenon that looks sort of like this. There's my depth. I checked the outside diameter here and compared it to the inside diameter here. So these are really handy. Outside measurement, inside measurement, depth of measurement are all identical. So whatever I measure here is represented in the other 2 locations. Very convenient to have. There's a little knob here that allows me to lock it so it doesn't go slip on me when I need it. And there is a scale on the face in inches and in millimeters. So if I really want to set a tenon for, let's say, 2 inches, well, I come up to 2 inches. So this is a really basic thing. The other reason I wanted a good scale is when I cut that tenon, if my scale has been cut perfect, it'll have a nice square corner on the end, and I can check whether that tenon has been cut squarely by simply setting that down in there and looking to see if there's a rounded corner in the bottom, which I must eliminate. The other thing for vessels, if I want to check to see I have a continuous curve, early on, many turners have difficulty in seeing what I would call a flat on the vessel. One of the easiest ways to do that is take your scale, take your vessel, and as I roll that around the curve, I'm watching to see that it is only touching at one single point. If it touches over an area, then that area is a flat and something that you'd want to go back and work on again. So your scale, we're checking curvature, checking perfection of tenons, taking absolute measurements, being heavy enough that it fits into my pocket and I don't drop it. So let's go on and take a look at some other things. Just a couple minutes. I cleaned up the area, got rid of the basic tools, and I want to talk about measuring wall thickness, either on bowls or hollow vessels. Sometimes measuring something like this is a little simpler. At least I got my fingers so I can do this. But when the vessel becomes curved and we have to get around some kind of internal shape, it sometimes becomes more difficult. Also, sometimes my fingers don't reach all the way to the bottom. So going back to our basic tools, remember we talked about having a pair of these calipers for measuring diameters like that. We can also use them as a basic tool for measuring wall thickness. Here's how it works. This is an old technology, old technique. So what I'm going to do is set them to some dimension here, maybe about 3/16. I'm going to take my bowl and I put that over there. It's a little thicker than that. Well, I now know what the wall thickness is, but I'm going to open it up a little bit more. And I'm going to see some clearance. I'm holding it up here between me and the camera. And as I slide this down the side, inside, I'm looking at how close the bottom wing comes from touching. Now there it's about the same, and now it looks like it's getting a little closer as we get closer to the bottom. And there's where the curve starts to come inward. So that means that the wall is getting thicker as we go down. Works really well. And if that was too far apart, you can always tighten it up and do another measurement. Years ago, David Ellsworth came up with the same concept, and you can make your own out of a piece of aluminum rod. I went to the hardware store, bought a piece of, looks like 3/16 aluminum, cut it in half, gave half to a friend, and I bent them into a circle, but these 2 points are at 90 degrees to each other. Let me show you how this works. Same thing again. If I go down on the inside, I can see the amount of clearance as I come around, and you can see that that clearance changes as I get closer to the bottom. That works really fine on the bowl. I can also turn it upside down and do it that way. But the idea of having them bent to 90 degrees is to allow me to get inside. Well, that doesn't work very good, but I can go in like this and check that wall all the way to the bottom. Well, this is a thin wall and this is not set properly, but I can readjust these. Just like that. So an easy set of calipers to make and to use is an aluminum rod, aluminum because it's bendable. Again, these tips have to be rounded off so you don't damage or scratch or mar your project. But the trick in this is make them big enough that they'll fit inside any of your projects, and at the ends are at 90 degrees to each other like that. Easy to make, easy to use. Works just like this did. Smaller calipers, smaller vessels, same thing, I can adjust this. Be cautious about these small ones, these ends, even rounded off, tend to dig in a little bit. Well, some of the more common ones we see in different sizes are things like these figure eights. Whatever is on one end is represented on the other end. And I can lock them for a dimension, or I can leave them loose and do the same measurement again. What I'm looking at is not down here where I'm measuring, but up here at the top. Look at there. You can see it's slightly getting thicker as it goes towards the bottom. Figure eights means they can fit around curves very nicely. Oops. I can come in here and check the curvature of this. Ooh, right down here it's getting a little thicker. It's pretty thick. Not so bad coming up to here. Now, underneath this rim, it's really hard to get these figure eights to fit in right. So sometimes we use this pair, which is again the same idea. This dimension here is the same as this dimension here. The advantage of these, not only can I measure like this, but if I wanted to measure the shape of an opening, I could measure inside here and take my reading by observing the opposite end. These are a little snug because I wanted them to be that way. I can loosen them up by simply loosening this nut, and allows me to use these more freely. There's lots of calipers on the market, just lots of different ideas about how to do the measurement. One we've used at school a lot, and a favorite of mine at home is this one, which is made by Mike Jankowski and sold through the woodworking dealers. This is almost the same as those Ellsworth calipers, except Mike brought the tip around, and whatever this distance is here is the same on this end here. So what the thickness of my finger is represented by looking over here. And being that they're D-shaped, I can check here, I can check all the way down. Now, one of the problems with calipers is right here. If my measurement is straight up and down, I get that. If I'm a measurement at an angle, finger's the same thickness, right? There's one. What if I measured it at an angle? I'm going to get a false reading. So be very cautious in using calipers inside a vessel that you're taking the readings vertical to the surface that you're looking at. When I get down here like this, I'm at an angle, and I'm getting a false indication. This one, now I'm getting down where I'm going to a little bit of a tangent. See the angle? If I was vertical, straight up and down, I would have gotten a different reading. So calipers need to be fitted to the project you're looking at, and sometimes it takes more than one pair to take a specific kind of measurement. Last one I want to show you, it looks a little different on the market now, but Gadget makes a tool like this, which is really nice. These brass balls won't mar as they slide along the surface of a project. And the other end, which you may not see on the camera, is marked on 16th inch lines here. So I can read this and tell how thick my finger is. Again, tangent measurements. But for a bowl like this, how easy it is to see the variation in the thickness just by sliding this along. That direction, for some other project, figure out how to hold this here. Going the other direction, trying to keep it on the camera here. Same measurement. The key is the shape allows you to go in one of two different directions, whichever works best for the shape that you're looking at. One caliper thing that you should always remember is start off by learning what your fingers tell you. I can tell by sliding the down here that it is getting thicker. Then I can check that with the calipers and start calibrating your fingertips so that you can tell a lot of information just by touch. So that's a quick review of some of the ways that we measure things. Precision, accuracy, whatever we need for the kind of work we're doing. Mostly for tenons, for wall thickness. Find a set of calipers that work for you. Apply something else, different techniques, or for any other reason, make your own. So that's a quick overview. Hope this helped. We'll see you in the next lesson, where I'm going to talk about cutting end grain, something a little harder to do than the cross grain for spindles and normal bowls. Cutting end grain. See you next time.